Okay, so you're probably wondering, well, what are these arithmetic and geometric sequences? So here we go. I'm going to go over these two things. An arithmetic sequence. As you can see, I have the definition written out here on the side here. An arithmetic sequence is where you add a constant to each previous term to get the new term. Okay, so that's what it means. This means to get to the next part of the sequence or the next number in the list of numbers here for the sequence, you add to it. So for example, like on A here, you would see that we are to go from -4 to -1 is +3. From -1 to 2 is +3. From 2 to 5 is +3. Okay, so your sequence generator, as some people will call it, or like your growth or whatever in this case, is adding 3 each time. So that's what makes this one an arithmetic sequence, because to get to the next term, the previous term was 5, so I add 3 to it. So 5 plus 3 would get me 8. And then 8 would get me to 11, and then 11 would take me to 14, and so on and so forth, because we could continue that list, okay, of numbers by adding 3 each time. Okay, so like an example in the chart here, you would see from -3 to -2, okay, that's the term number. Okay, that tells you what spot we are at in the sequence. Okay, the term number tells you what spot we are at. Okay, from -3 to -2, you see that the y value here goes from -14 to -9. Well, that would be +5 each time. Okay, from -9 to -4. Okay, from the -2 term to the -1 term, you still add 5. You can see that from -9 to -4 is adding 5. And it goes on from the term 0 to 1, and from 1 to 6. Okay, that's what the y value is. That's what the actual number in the list is. That is +5. Okay. Now, one thing that is unique about arithmetic sequences, since we're adding everything every time, we're always adding, it is going to have a representation of a linear graph. Okay, so that's the unique part about these arithmetic sequences. It is going to be a linear graph, which means we know how to graph that, so it should be in some kind of form of y equals mx plus b, which has a slope. Remember, slope is your growth. It is growing at the same thing, and you're adding it each time here. And that's what an arithmetic sequence represents, okay, is y equals mx plus b with the constant growth of adding a number each time. Now, we got to remember that sequences are discrete, okay, which means they only happen at the points. So it'll be only at these points, so we would not connect these with a line. That's why you can see here on this example, on this graph, they're just the dots that have been plotted, okay, so you just want to connect them. So that's what an arithmetic sequence is. Now, geometric sequences, that's the other type of sequence that we can have. And what that means is now instead of adding, we're going to say multiplying, okay? We're going to say multiply by a constant. So that's the other type of sequence that you can have, is when it's multiplying, okay? So for example, like this G here, okay? It's going from 48 to 24. Well, I know a lot of you guys are saying, oh, it's going down by half, okay? Or it's dividing by 2. But think about what's another way of dividing by 2? Well, that would be saying times by 1/2. Okay, same thing from 24 to 12. Okay, that would be timesing by 1/2. So to get the next number, you would take 12 times 1/2, which is 6. And then from 6 to the next one, take it times 1/2. Okay, you would have gotten 3. And then you would get 1.5. Okay. So you can see I'm multiplying by a constant each time from the previous term to get my new term, okay? And the same thing goes for like h. H would be times by 1/3, okay? Times by 1/3, times by 1/3, and so on and so forth. Now, it might not always be a fraction, though, like that. So you can see here in this chart here, I go from 1 to 2 in my y values. Then I go from 2 to 4. Then I go from 4 to 8. Well, that's like doubling. Well, that means timesing by 2. Okay, so timesing by 2 is another way. So we can not only does that be it doesn't have to be a fraction, but it can be a number bigger than 1. So we can have both of those there. All right. But for a geometric sequence, it is multiplying by the same thing. So as you can see here, this example of the graph, okay, I believe this is let's see here, we have a sequence generator of 2, it looks like. So this is the table. Okay, you can see here. It's the same thing as discrete, so it's just plotting each point. We're not connecting them. But you'll notice here it starts to grow faster and faster and faster. So even if I were to graph 2, actually this one's not 2, but You can see it's growing faster and faster and faster, okay? So therefore, it's not going to be linear. It's not growing by the same thing. We're not adding the same thing each time. It's getting bigger and bigger and bigger. The gaps between our numbers are growing. Okay, as you can see, the gap between these ones were 2. This one is 4. This one is 8. This one is 16. Okay, they're not getting bigger by the same number each time. They're multiplying. Okay, so it's getting bigger. The points are going to get further and further away as our x value gets bigger. And if I were to graph the next point, I would expect it to be somewhere up here, then way up there, and so on and so forth. Okay, so a geometric sequence cannot be represented with a linear graph. It actually has a special name, and it's called exponential, and that's what we'll get to in chapter 7. Okay, but you need to be able to recognize if it's a geometric sequence, and a geometric sequence means when you're multiplying by a number each time. So that would be your sequence generator. Okay, if you have any questions, please let us know, okay, as we will continue this here in the next couple weeks.